So I'm going to go through this. I'm going to use number 2 as an example for what we're doing. We're looking for the perfect square. Certain numbers, if you look at the enzyme, that's a perfect square. That's a perfect square. 169, 25, 144. I have them memorized. Most people should to some degree. Not, you take the square root of the number at the end. If it's a perfect square, it makes the problem a little interesting because you can actually do the problem fairly quickly, right? So I'm going to just go ahead and erase all this. We're going to have it all marked up when we're trying to work through this. But the idea behind it was like we're looking at that last number. And we can also look at the front number. So if these are perfect squares, where that way we have perfect square, we take the square root of 36, you get 6. And the square root of 144, you get 12, right? You can easily do some of these problems without having to try to 36 times this and figure the whole thing out because they're perfect squares. I'll show you how we're going to do it. So I'm going to first start with that first problem where it says 2y, actually it's y squared plus 8 plus 16. Off the right top of my head, I know that 16 is, if you take the square root, is equal to 4 squared. So my factors for this, right, in a perfect square universe, would be 4 and 4, and I put my y here and my y here. I want to get 8y in the center. So I can look at this, and after you've been doing enough of these FOILs, it pops out for you. So watch this. Y times y is y squared. Y times 4 equals 4y. 4y times y equals plus 4y. And last one is plus 16. Now if you pull this together, what do you get? Y squared plus 8y plus 16. Okay? You'll start seeing them based on the fact there's a perfect square. There's a perfect square up here in the front. It's just 1. So you just ignore it. You don't have to deal with it, right? But there is a perfect square there. It's 1. It's the first one. That's kind of what you're saying. Let's take a look at one of these other ones, right? Let me grab this guy, number 5. I'm just going straight down the center of it. So I actually have 1 squared, right, which would be 1, C2 minus 20C plus 100. Is 100 a perfect square? Yeah, it's square root of 100 equals 10. So I know it's going to be C10, C10. Now I know there's a 1 in front. It's implied, and we drop it. But how do I get a minus 20 out of it? Well, if I put a negative 10 on both of them, I get the right answer. FOIL it to make sure. C times C is C squared. C times minus 10 is minus 10C. Minus 10 times C is minus 10C. Minus 10 times minus 10 equals plus 100. Grab a line. C squared minus 20C plus 100. Boom, it checks. It adds up to where it's supposed to be, right? Let's grab number 8. I'm just going straight down the middle of these things, okay? I just erased it. We'll go ahead. I have now 4r squared plus 12r plus 9. This may look a little confusing, okay? And you might be saying, well, I don't know how to do it when I get to this. I know that this, if you take the square root of this number, you have a 2. Square root of this one, you got a 3. So it must be 2r plus 3 times 2r plus 3. If it works. This is plus, so I can't even have a minus. I just know it's got to be a plus, right? Factor it. Let's see what happens. 2r times 2r, 4r squared. 2r times 3 is plus 6r. 3 times 2r, plus 6r. 3 times 3 is plus 9. Add them together. 4r squared plus 12r plus 9. Check. Makes sense, right? I'm going to try this real wackadoodle one down here. Let's see what this looks like. Oh, it's got a lot of weirdness going on, right? So, once again, let's see what I come up with. I got 36 r squared plus 144 r plus 144. This may or may not work. It says determine whether each is a perfect square. In our case, it is, right? We can tell. Should have it memorized. This is a 12 squared. This is a 6 squared. Let's work this out. So if I put 6r right? Plus 12 times 6r plus 12. Let's see if that works. 6 times 6r is 36r, right? 6 times 12 is plus 72r. And then we go, this is plus 72r. 12 times 12 is plus 144. Easy enough, right? 36r, it should be squared. R squared plus 144r plus 144. Oh. Okay. Hardest ones down here are these fractional ones. Okay. And I'm just kind of leaving those out right now. We're not going to do these. But the other ones are kind of the same. I'm going to show you a couple of these. These things are factor the binomial if it cannot be. This one factored out real easy. This one's interesting. Okay. We'll try this guy. We have x squared minus 169. If I look at this thing, this is 13, right? 13 times 13 equals 169, so the square root of 169 is 13. I would put down x minus 13 times x plus 13. They're going to cancel themselves out. Let's try it out. FOIL it. X times x squared, x times, that's going to be plus 13x. This will be minus 13x, and this will be minus 169. Drop a line. X squared, this goes away, minus 169. Cool. Now I'm going to grab one of these wonky looking ones down here because this is factored completely, right? This is stuff you've done previously. It just looks a little more difficult because it's expecting you to remember what you've done before and apply it to what we're doing now. And this would be QR3. Remember this, I take out my Q. I take out my smallest Q, which is both of them. I just put a Q to the outside. Size up with 4R minus R3. Then I see which one. I can take out an R now. I'm going to take this one out. And what I'm doing is just this, just dividing both by R. So I end up with QR equals 4 minus R squared. Now, is that perfect square? Yes. Is that a perfect square? Yes, in a way, right? You can now make this 2 minus R times 2 plus R times QR. Right? Super tricky. Let's try this guy. These are kind of goofy, right? 18e squared minus 21e cubed. Let's get rid of this first. So that'd be e squared times 18 minus 21e, right? Remember, we were doing this before, right? 2 minus 2, you get nothing. 3 minus 2, you get 1, so you got to leave 1 in. Now I can turn around and let's say I divide them both by 3. Divide that by 3. Divide that by 3. So I can put the 3 up here to the outside. 3e squared equals 6 minus 7e. That's it. We're stuck. Can't do anything else with it, right? That would be the answer to that problem. I'm going to grab this guy now, and this will be the last one I'm going to do, all right? So pay close attention. This says 24f3g minus 28f squared g squared. All right, this may be challenging. Let's go for the back letter first. G, let's take him out. So I rewrite it. I make sure I'm doing this correctly. I have 24f cubed minus 28f squared g. Let's get rid of some f's. So we're going to take this guy out. So that's going to make that a 1. So it's going to be f squared g times 24f minus 28g. Right? Let's say I want to factor out a 2. Right? You do this in stages. I'm doing this on purpose, right? The 2 is going to come out in front. 2f squared g times 12f minus 14g. I can factor another 2. Divide by 2, divide by 2. That means this comes up and multiplies. Your answer is going to be 4f squared g times 6f minus 7g. Hopefully this helps a lot and it makes more sense after going through it.